Hey guys, just checking in quickly on Tuesday's assignment. The only question I had was number 75, and the function was this here, and it asked for the critical numbers. So we derive f prime of x, and we're going to need the product rule. So first times the derivative of the second, which is going to require the chain because there's a function within the cubed part. So times the derivative of what's inside would be times 3. So this 3 going out in front comes here. 3x minus 1 drop down to the second power times the derivative of what's inside that 3. So first times derivative of the second plus second times derivative of the first is just 2x. And then if I'm cleaning this up, I have 9x squared, 3x minus 1 squared, plus 2x, 3x minus 1 cubed. And if I'm factoring, I'm going to pull out a 3x minus 1 squared. That'll leave me with 9x squared plus 2x 3x minus 1, and actually I just realized I probably should have taken out an x. Well, I can still take out an x from here, so x 3x minus 1 squared. So the x pulled out of here and here will leave me with 9x plus 2 3x minus 1. That'll be 9x plus 6x minus 2. So 15x minus 2 there, 3x minus 1 squared there, and x there. So my critical numbers are anywhere where it's undefined, which it's not, or equal to 0. So we get x equals 0, x equals 1/3, or x equals 2/15. Now these are the critical numbers. This does not necessarily mean that they have to be extrema. So 0, 1/3, and 2/15 on this problem is option D for the multiple choice. I'm just going to take it a step further because there may still be some confusion on this. So they are critical, and critical numbers mean just that they have the potential to be an extrema only if they're increasing on one side and then decreasing on the other, or decreasing on one side and increasing on the other. So we have 0, 1/3, and 2/15. Wait, this is the same as 5/15. So 2/15, and then I'm going to go call it 5/15 just so it's all relative. Okay. So if I plug in a -1 here, I'm going to get a negative times, that's always going to be positive because you're squaring it, times -15 minus 2 is another negative. And a negative times a positive times a negative means the function is decreasing right there. Right after at 1/15, it's going to be a positive times always positive because we're squaring it, and then 1/15 is going to be 1, 1 minus 2 is negative, so that's still a negative. So even though this is not a relative extrema, so it was decreasing coming into 0 and then it continues decreasing out of 0, so it's not a relative extrema. And then on this side of 2/15, like let's say 3/15, we have a positive times a positive. 3/15 times 15 will be 3. 3 minus 2 is a positive. Okay, so then it starts increasing at 2/15, so that is a relative extrema. And then 6/15 will be a positive times a positive times 6/15 will be 6 minus times a positive. So it's increasing into 5/15 right at 5/15. It's going to be 0, but then it's increasing after it as well. So that's not a relative extrema either. But they're still critical points. So that's why the answer is D. So there's definitely a difference between critical points, which you'd stop there, and relative extrema, which means you need to check inside and outside and make sure there's a shift between decreasing to increasing. So that would be the only relative extrema here. Just because it's fun for me, and this is what I would do in class, I'm going to graph that original function and let you see how that behavior is happening. 3x minus 1, oops, cubed. Okay, so the critical stuff is happening. Invalid, go to, what's going on there? Oh, there's, that was probably my children. Okay, so the critical stuff is happening between 0 and 1/3, really. So if I go from like -1 to 1, that should show me. Okay, I'm not quite seeing the imagery that I was seeing there, but if I, why at -1 do I have it decreasing, but this is showing it increasing? See that -1, the graph is definitely increasing, but my test shows that it's decreasing. Check that negative again. Oh, duh. So I've been screwing up the entire time. A negative times a negative is a positive times a positive is a positive. So it was increasing. So now I take it back. Still no difference in my final answer. These are all critical points, but this is a relative extrema. This is a relative extrema. That one is not. So we're increasing until we get to 0. We don't really see the decreasing much, but I bet if we changed our window and zoomed in a bit, we would probably see more of it. At 0, actually doesn't look like it's turning around, but it's got to be. If I zoom in some more, right around here, let's see what happens. It's right along the x-axis. Window -1 to 1, and then I'm going to do -0.1 to 0.1. There it is. Now you see it. So it came up at 0, it turned around, and then that was where at 5/15 we had a little bit of a wiggle and it kept going. So it's increasing, decreasing, increasing again, little wiggle, increasing again. So increasing, decreasing, increasing, increasing. You definitely sometimes have to monkey around with the window to really see what's going on. Increasing, decreasing, increasing, increasing again. And that's -0.1 to +0.1. So that took some persistence and some confidence that I know that this is right to figure it out. If I wanted to be even more obnoxious about it, -0.01, +0.01. I don't know why I'm beating a dead horse here, but yeah, that really shows it. Increasing, decreasing, increasing, little curvature, but continues to increase. So that's why we have the 4 critical points, or the 3 critical points. 1, 2, 3. And that critical point does not end up being a relative max or min. So, any other questions, send them my way, but hope you guys all are having a good week, and hopefully you'll hear from me over the next couple days.